Hi, I'm Jasmine, and I'll be walking you through design patterns in Azure Cosmos DB. We'll talk about what makes them so great, and then we'll categorize them into three particular categories, and then we'll apply those to particular design patterns in Azure Cosmos DB, where we have a really awesome repository that covers all of the design patterns that the team has been writing about. And then we'll get into two particular demos that kind of focus on two different design patterns across two of these particular categories. Now, design patterns are nothing new. We use them to solve common problems that we as developers face. And they essentially help us build reliable and maintainable software that really stands the test of time. And, in this vast universe of design patterns, when we think about them, we're often thinking about software constructions and software construction and software development. And we can really break them down into three particular categories: creational, structural, and behavior, where creational is focused on things like object creation, where we want to create them in a manner that is suitable for a particular situation. One really popular one is the singleton pattern that allows us to maintain an instance of a class to make sure there's a single point of access and entry, as well as a single point of failure, in which this actually helps us maintain behavior and resource management. And then let's get into behavioral. This is really around algorithms that deal with the assignment of responsibilities between objects, like the observer pattern. That's another popular one where one object is responsible for notifying any dependents of any changes and changes in the software. And it's often used in things like distributed event handling, where state consistency is key and is important. And finally, structural, where we focus on how objects are composed to form larger structures, like the adapter pattern. This essentially bridges incompatible interfaces that are often used in things like new features and components and things that are essentially introduced into an existing code base. And when we think about data architecture, we can apply these same categories. So in again, these same categories, structural patterns really apply to how the data is organized and stored and accessed. Creational focuses on the dynamic creation of these schemas, where dynamic creation is really a big key point in NoSQL architecture. So things like tables or containers, indexes that may change over time, and these are really focused on an application's need. And then finally, behavior, where we focus on how the data is accessed and manipulated and how those changes are actually propagated throughout our data set, throughout our container, and throughout the items within it. So as I mentioned before, Azure Cosmos DB has a design patterns repo that kind of focuses on all these particular ones here. So between structural, creational, and behavioral, and they're actually a repo that kind of illustrates in code how these all work. So from attribute to array to materialized view, we can see there's one right now on creational called pre-allocation, behavioral like distributed counting, document versioning, schema versioning. Some of these you might have heard before and can actually also be applied to other NoSQL architectures outside of Azure Cosmos DB. So with that, the moment you've been waiting for, we're going to get into two particular demos. First, we'll look at the structural type called attribute array, and then we'll move on to behavioral under distributed counter. So I'm going to go ahead and move on to my repository here. And just want to show you the Cosmos DB design patterns repository. It has a bunch of information about these particular design patterns, how to apply them, especially also how to apply or how to use the demos within them. So first here, the attribute array is really focused on working on multiple name value pairs that have similar data. And what we want to do is really turn these into arrays and actually make them part of the parent object. Now, the benefit of this is that it makes querying a lot more easier, and it also, allows us to make it a little bit more performant and essentially efficient to index, and makes our queries also a little bit more concise. So in one particular situation, think about when you have a e-commerce store. Maybe you have a particular product that has 3 particular categories. So for example, shirts that come in multiple sizes: small, medium, and large, and so on and so forth. So you could, a whole range of shirt sizes. And let's kind of walk through the documentation here. So so here's like an example of like kind of what that data could be modeled like in like essentially like, for example, a database schema. And this is what it would look like in Azure Cosmos DB. We have this particular shoe product that is broken down into small, medium, and large, and we can see that this can be a little bit of a challenge to query. So look at this, look how big and complex this query is. But what if we were able to essentially massage this data and make it into essentially a set of arrays? Specifically, these sizes get turned into arrays, and then we can make this into a more of a cohesive and more flexible query. So let's take a look at what this looks like in our code. So I'm actually not going to get into the code in particular because the demo code essentially creates the collection for you. But what the code actually does is it allows you in the command line to see kind of what the data that's being stored in your NoSQL database looks like. So for example, here I have this one product called an ergonomic plastic mouse, and maybe I do know that mouses do come in different sizes. So maybe we do have a set of small, medium, and large mouses for our customer base. And here we can see that we can take a look at also the some additional products here, or some additional massaging of those products to really reshape this collection into this attribute array pattern. So what I'm going to do is actually take a look at this in Azure Cosmos DB Data Explorer. So let me just show you what a particular item looks like. So let's take a look at that same mouse. And we can see that we have this very, I wouldn't say inefficient, but one way for us to really describe these mouses and these sizes. But what if we were able to apply this with the attribute array patterns? Let me find that here in the list here. So we can see that what all the attribute array pattern really does is allows us to change the structure of our items so that we can easily query and break down these particular sizes break down these particular items or attributes into particular categories. So let's take a look at some queries here. So as I showed you before in the repository, we have this really complex query where we're getting all of pulling all of the items from our collection. And here I'm looking for items that have a query or a quantity of 75 or greater. So let's see if I run this. And let's see if I can open this up. We can see here that I have my ergonomic plastic mouse, and I can see that it's actually pulling in all of my items. So this will require maybe a little bit more massaging to really get what you need, but either way, it's going to take a lot more work to actually pull out the items that actually have 75 of a quantity or greater, which would in this case be medium and large. So even if I did something like this, so like say that I like commented out this and ran this again, see I run to an issue and all kinds of things. So let's actually move on from this and take a look at, I'm going to comment this out, and let's take a look at a different way to really run this query. So let me uncomment this and let's go ahead and get started. And so here we go. As first thing you can see is that this query is actually much smaller. And here we can I have my count, and I join my products item with my sizes, and then I go and I find everything within that sizes array that has a size of or a inventory of 75 or greater. So let me go ahead and run this and execute this query one more time. And there we go. And now we can see this is actually returning our objects our mouses with the proper quantities and the sizes to match. So that's great. So again, this is something that you can try out yourself in the repository. Now we're going to go to a little bit more of a complex design pattern called distributed counter. And this is what this really is for when you're doing things like real-time updates. So say that, that same product, that mouse product is really flying off the shelves. How do you manage inventory so that you don't run into a situation, or the user or a buyer doesn't run into a situation where they might have an incorrect idea of how many mice that they can actually buy? So the idea around this is, essentially creating these multiple distributed counters using the value of one primary counter. So this counter essentially splits off into multiple counters to really manage the number as well as the value of these counters at any given time. So there's a lot more that is going on here, but the idea is that it's supposed to prevent you from running into situations where you might have issues with concurrency, and also allow you to be able to find how many items you have left in any particular given time. So we're going to go ahead and run this simulation of the distributed counter. And this particular counter is a .NET application that has a Blazor front end that allows us to really see these counters working in real time. So what I'm going to do is I'm going to actually hop into our distributed counter demo here. So here's our little application, and I'm going to go ahead and create the counter. And now I have my counter here, but notice that here is essentially my primary counter. This is a counter that holds my initial value, and then this is going to be split off into these multiple counters. So what I'm going to do here is copy this ID, and then I'm going to hop into my application here and do .NET run. And this is what's going to essentially simulate those counters for me. So let's go ahead and just give this a second to run. And that counter ID I copied, I'm going to paste right in here. And we're going to say, let's say that we do, 5 worker threads. And now we see all of our threads running. And if I take a look here, we can see all of our threads here working across this visualization. And here we can also apply the idea of like splitting or merging these counters. And what's good about these is that, like, if you need to split a counter, you can essentially meet the computational load of maybe more people coming to get to buy your items, or merging them to scale back these counters when the demand dies down. So this is another really great demo that you can try yourself as well. And again, these come with full sets of instructions on how to use them yourself and how to get started. So going back to the slides, we're going to wrap up here. If you want to try this yourself, like I mentioned before, you can go to aka.ms Cosmos DB design patterns. In there, you will find, actually, this link here actually refers to actually a blog series created by the product team that kind of goes into depth on what these design patterns are for and how to apply them and why you'd want to use them, as well as references to the actual repository that walks through these in detail and through code. So I hope you give it a try, and thank you so much for coming to this session, and I will see you I'll see you online.